Okay, let's try to answer this question. Say we are given this IP address here. And the question says, assuming classless addressing is used, and you may assume each subnet does not need a network and broadcasting address. Distribute IP addresses to the following faculties in a university. Then we have number one. Let's focus on the first one. The first one says the faculty has 64. There's 64 departments, and each department needs 256. So this department is the same as customer. Same as customers. If you wanna look at it like that, you can use it as same as customers. And then each customer needs 256 addresses. So the way I like to simplify my life all the time, using a calculator, going to have log 2, and then here 256. If you punch this in your calculator, it's going to give you 8. Then remember that 2 minus 8, it's going to give you 24. We call this it's the prefix length, and we always subtract by 32. We always subtract from 32 with the number that we got from our logarithm function. So okay, then from here, the question says the first faculty has 64 departments and each needs 256 addresses. So let's start with the first department. We just do this first department. So the first department, we remember now we have this value here, 24. We are going to, for the first department, we are going to have 19. Let me use a different color. Going to have 190 and 100 0 0 24. We use this value that we got from our calculation per se, 24. And then this is the first department. Each department needs to have 256. And this value, the 256, we subtract 1. Because here we see we're starting from 0. Each and every time we need to subtract 1. We actually need to subtract 1, so that we're going to have 255. This means that it's 256 addresses. So starting from 0 to 256 to 255, this is actually 256 addresses. Hopefully you do understand that. So here we are starting from 0. We are going to have all the way 190, 100, 0, 255, 24. Now this department has been allocated exactly 256 addresses from 0 to 255. That's 256 addresses. Now we go to the second department. The second department. On the second department, remember that on each and every octet, I'm actually referring to this, we have 4 octets here. These are 4 of them. On each and every octet, the value must be between 0 and 255. It should not exceed this value. Okay. So on the second department, notice that here we have reached 255, which means we cannot go beyond that. So for the second department, we're going to have For the second department, we're going to have 90. What are we doing here? We increment this value here. Actually, we increment from this value because this was our latest address, if I put it in that manner. We incremented this value here. We're going to have 1 here, and this is because we have already reached the maximum octet value here, which is 255. We cannot go beyond 255, so we're actually going to have 1 here, and then this one is going to be 0, 24. Remember, we are moving all the way to each department needs to have 256 addresses, so it's going to be 25594, because from 0 to 255, that's 256 addresses. So like we're using the maximum. Okay, now we move to the, now here's where it gets tricky. We cannot calculate all this department like 1, 2, 3, 4 until to the 64th department. That gets tiring. That really gets tiring to do so. So you need to actually skip here to the 64th department. But this is where you have to be smart with it. Now we're doing the 64th department. Sorry, let me actually erase this one. It's the second department. This is the 64th department. Notice the pattern here with these values here. In the starting address for each department, the first we're actually using the zero-based indexing. If you notice here, if you notice here, this is the first department, and the third octet is 0. So that's zero-based indexing. So which means when you are on your 64th department, you're actually going on your third octet, you're going to have 63. Hopefully you're noticing that pattern as well. So here we're going to have 9011 630 24 100. Need to put 63 here. 63 255 24. We are actually done with this question. Now we are moving to the second, just call it a sub question. Now we're moving to this one, the second one here. Okay. When calculating these, or when answering these questions, we continue with the last IP address that we have used. We do not start from the one that we were given here. No, we actually continue with the last one, because notice that this is still the same question. These are just sub questions. This is still the same question. So we actually continue. Okay. Let's go to question number 2. Question number 2 says the second faculty has 128 departments, and each department need 128 addresses. So it's 121, 128, 128. Now, the first thing we focus on is the number of addresses. Make use of your calculator here. Using the calculator, it's going to be log to 128. If you check this on your calculator, it's going to give you the value 7. Then we need the prefix. Length, it's going to be 32 minus 7. This is actually going to give you 25. So we're actually going to replace this on our upcoming calculations. We're going to replace this 24 with the 25. Hopefully that makes sense. So here says the second faculty has 128 department. Now let's start from the first department. the first department, we're going to take the last. We are going to count from the last, not actually take. We're counting from the last. Notice here the last was 190.100.63.255. And remember that this value, we do not go beyond this value. So now we are starting a new department. What we're going to have, it's 190, 100. We increase the value before. So we're going to have 640, then 25. The reason why we are using this 24 is because we've already allocated that other address to the other to the other group, the 64th department. So we cannot try to access that address again. So we're actually going to have this new address here. And then the value, they say each department actually needs to have 128 addresses. Now we are not going to increment by 255 like we used to do. Now we are incrementing by 128 because each department needs 128. So we're going to have 190.100.64.127. Reason being is, look here, if we have each department must have 128 department from 0 to 127. This is actually 128 departments. Okay, meaning now on the second department, we are going to have 190.100. We're actually continuing from that 64 because we haven't yet used the maximum to the maximum value point. Remember, the maximum value point has to be 255, right? So here we're actually going to have 64.128 plus 25. And then if you increment this value here by 120, you increment this value by 128, we are actually going to have 100.64255. If you count from 128 to 255, that's actually 128 addresses being used. Okay, here we are actually done with department number 2, the second department. But however, remember, we cannot calculate all these departments, department 3rd, department 4th, 5th, like it's going to take time. Now we actually have to move to the 128th department. Now try to check that pattern again. See, if you try to check this, you will realize that now it's a little bit difficult to determine or to use that method that we were using that other time of checking whether we are using a zero-based indexing or what. It becomes hard. This is where we're going to use this formula. Let me show you the formula here. So this formula actually requires you to take the first, from the current question that we're solving, we take the first starting address from the first department. It's 190.100.64.0. This is the I was saying from this address, this is from the first department right here. It is from this address. The first thing that we need to know is to calculate how far to jump from the first department to 128th. So let me even write it down. how far to jump to 128th department. So we're going to use this formula, how far I, and it's equal to minus 1. Here we have 128 minus 1, it is equal to 2. This is how far we need to jump. And this, remember, this is because of the department 1 is offset 0. If you come back and check here, it's offset 0, department 1. Then department 2 is offset 1 times 128. If you come check here, but either way, that doesn't really matter a lot. The fact that you just have to know that how far do you have to jump to 128th. Okay. Now let's calculate this offset, which is going to be offset. It's equal to I times the block size. I times the block size. Our I, remember, it's 127. This is our I. And what is our block size? Our block size is 128. This is the value that the block size is actually the block size is actually the number of departments per the number of addresses per department. This is our block size, the number of addresses per department. That's our block size. So we are actually going to have 127 times 128, and this gives us 16256. Then the second thing that we need to know is converting the offset that we got to octet to an octet. An octet we are referring, remember when I showed you an octet, we are referring to, say we're given IP address 1. I'm giving an example with this. Here we have 4 octets. So we are going to have 1 octet, it is equal to 256 addresses. This is because 1 octet is equal to 256 different values in an address. This is because each and every octet takes a value from 0 to 225. This is like 256 values. Do you understand that? 1 octet, it is equal to addresses, not value, addresses. So what we are going to do, we are going to divide our offset with the number of addresses per octet. So it's going to 256. You divide this, it's going to give you, divide this by 256, it's going to give you 63, remainder 128. So on this value that we got, you see this 63, it's going to increment our third octet. Our third octet, here is this third octet. But in this instance, this was just an example. In this instance, we are focusing on this. Remember, we are focusing on this. It's going to increment that one. Then this one, it's going to set our fourth. It's going to set our fourth octet. This is going to set our fourth octet. Octet. Yo, guys, sorry, my pronunciations sound really bad. Our fourth octet. Yeah, that. Okay, then let me recall this. Remember the first department, we had this value here, which is 9640. This was our first department for the second sub question that we're answering, first department. So what we're going to do here is for the third octet, It's 63 plus the current value that we have in our first one. The current value that we have here, which is the current value we have on our third octet. It's going to be 63 plus 64. This is going to give you 127. So which means for our 28th department, you're actually going to have 190, 100, and 127. This one is 0. Then you need the last address, right? You need the last one. It's going to be, you see this one sets the fourth. It sets the fourth. This one sets the fourth. Remember, this one sets the fourth. Sorry, apologies. This one sets the fourth octet. So you're going to have 128, just like this. You're going to have 128. This one sets this one you're actually going to add it to the current value that you have, and this one sets the fourth. So here it is 190.100.127.128. The remainder comes here. This one, it's the value that you got when you were calculating, plus the current value that you already had here. Then the ending address, this is just means of you trying to remember of what was happening. Just try to go back to your question. The question was saying, what was the question? The question is here. The question was saying the second faculty has 128 departments. Each needs 128. So each needs 128 addresses. You just come back here. You add 128 from here to, remember you are jumping using 127. Using this 127. So if you added this to this value, you're going to get 190.127 and 255. Remember, we have that 25 here that we always have to put here for our masking value. And then this is how you calculate this thing. Again, apologies for some errors there. But this is how you calculate it.